Hello, my beautiful people. This is Mr. Bear, and I am going to talk to you today about understanding the value of a logarithm. So, we're going to be connecting what we've been doing with exponentials to now looking at the logarithmic form. And to do that, we're going to start with understanding what this expression is read as. Okay, so when you see something that looks like this, we're going to read it as log base b of a. This b value is our base for the exponential, and the a is going to be known as an argument, which is probably something that you'll want to have with me once this lesson is over. Ha ha ha. All right, notice that our a and b values must be greater than 0, so that's just saying that they must be positive. Okay. So let's just remind ourselves that when we are writing anything in log form, I'm going to say log base b of a is equal to some value that I'll call x, okay? When I write this in exponential form, just know that that means b, so our base, the thing that the logarithm is equal to is our exponent. That's our exponent, which in this case is x. And the exponential always equals the argument. Okay, so we're going to go ahead and do a couple quick examples. So just following this pattern right here, I'm going to take something that looks like this and make it look exponential. Okay, so remember, we're looking for base 3. Then we look at what our exponent will need to be, which will be what the log is equal to. And it's equal to 27. Sorry if you were hearing some noise in the background. I had some cats that were trying to play in a box that I left on the floor. Don't ask. And they think everything that I leave on the floor is a toy. So anyway, don't want to get too involved in that. Let's just keep going. All right, so next one, we look for our base number, 2. We look for what the log is equal to for our exponent, and it equals the argument. The next one, 5 to the third equals 125. Next one, 10 to the third equals 1,000. All right, those were probably the easy ones. Let's look at some harder ones here. So this one says 36 to the 1/2 equals 6. Why do I know that? Well, if you remember, I talked about the flower power analogy for these exponents that are fractions. So numerator holds the power, denominator is the root. So remember, if you think about the flower growing out of the ground, the roots hold the flower in. It's an ugly flower. The pretty flower leaves are on the top. So that's how you can remember this. So we have a root of 2. That's a square root. The argument's 36. Well, the argument isn't really 36. The base is 36. The power is the 1. So square root of 36 is just 6. All right, next one says 27 to the 2/3 power equals 9. Well, I know that because if I rewrite this exponential into a radical form, I'm dealing with a root of 3, so a cube root of 27, and a power of 2. So this is cube root of 27, which is 3, and when I square it, I get 9. And that's what I got. All right, so now that I've done a couple examples of those, I'm not going to take too much more time on the rest of these. I just want to kind of make sure we get the pattern. 9 to the 5/2 equals 243. Okay, just think of that as square root of 9 to the power of 5. So 3 to the 5th. There you go. Next one, 10 to the -6 is 0.000001. And I'll use a calculator to figure that out. Next one says 5 to the 1/2 equals square root of 5. Well, we've already seen a power of 1/2. It just means square root. Next one I will explain in more detail. So this is saying 4 to the 4/3 equals 4 times the cube root of 4. And you may be thinking, Mr. Bear, that doesn't make any sense. And if I were a student in your position, I'd be like, yep, you're right. This doesn't make any sense. So I'm going to explain that one. Okay, so 4, so think of this 4 as 4 to the first, and this cube root of 4 as 4 to the 1/3, because the root is 3. Well, when we have exponentials with the same base and we're doing a product, we have to add the exponents. So 1 whole is 3/3 plus another 1/3 makes 4/3. And that's how we get that exponent that we have. All right, next one, 3 to the 1/5 equals 3 to the 1/5. Yep. 4 to the -2 equals 1 over 16. Remember, 1 over 16 is 1 over 4 squared, which is 4 to the -2. Next one, 5 to the -3 equals 1 over 125. Remember, 5 to the -3 equals 1 over 5 to the third, which is 1 over 125. That's why we know that. Next one, 5 to the first equals 5. Yep, we know that. Last one, 6 to the 1/3 equals cube root of 6. Well, yeah, because we have a root of 3, so it's cube root, and an understood power of 1. All right, so those are some basics. So if I wanted to find any value of log base b of a, well, if I say, so I'm going to write a conditional statement, so think back to geometry. If y equals, now let's write this differently. If log base b of a is equal to y, then b to the y equals a. Okay, so this is log form. This is exponential form. And notice that the two are inverses. Okay? All right. So now let's talk about some other facts. So if b equals a, then what would be the value of log base b of a? Well, what this is saying is b and a are the same thing. So if I rewrote this, this is saying b to what power equals a. Well, remember, a and b are the same, so I could rewrite this as b to what power equals b. Well, b to what exponent equals b? Well, that can only happen when the exponent is 1. Okay, so log base b of a is equal to 1. The next one is saying, okay, well, if I have log base b of a, what will that become? Well, that's saying, okay, so b is less than a. So b to some exponent to equal a, that implies that, so remember, a is larger than b. So if I take b and I raise it to an exponent, okay, I'm going to get a larger number. So that's going to happen whenever the exponent I have is greater than 1, okay? So in this case, the logarithm would have to be greater than 1. So let's do an example. Let's say I had 2 to the something equals 16. So my b is 2, a is 16, b is less than a. Well, that exponent would be 4. Okay, so what that's saying is that the value of this log base b of a has to be greater than 1. Likewise, if b is less than a, so what would happen with log base b of a? How would that compare? Okay, so that means b to some exponent is equal to a. Well, this time our b is larger than a, so that means that I'm taking a value to an exponent and I'm getting something smaller in the end. So let's say I had like 2 to some power equals, let's say, 1/4. Well, in this case, we would have to have, this exponent would be -2. If I had 2 to some exponent equals 1, well, the only way that happens is if the exponent is 0. right? So it just kind of goes on from there. 2 to what exponent equals square root of 2? Well, that exponent would have to be a half. Okay, so anything that is less than 1 whole is going to give us that situation. Okay? All right, let's go ahead and try some examples on the back. So next we're going to practice using our calculators. So for our calculators, we're just going to practice using the log button. Okay? You have a log button on your calculator, and so just practice typing some of these in. So log 5, you should get 0.6989, so 0.699. For log 100, calculator gives you 2. For log 115, calculator gives you 2.061. I rounded those to 3 places. All right, so we'll use that idea in a moment, but let's try some of these out. So let's figure out between what integers, if it's not already an integer, the log expression will equal. Okay? So this is saying 3 to what exponent equals 81? Well, in this case, that exponent would be 4. So x equals 4. Okay? If I took log 81 divided by log 3, and it's important to make sure you're closing these parentheses after you do the logs. Make sure you do that. You would get 4. The next one is saying, okay, so we'll set this equal to x. So 2 to what exponent gives me 1/8? Well, that's the same as 1 over 2 to the third, which is the same as 2 to the negative 3. So x is negative 3. And if I were to type in this on a calculator, again, please make sure you close those parentheses. You would surely get negative 3. Okay, the next one, this is saying 2 to what exponent gives me 9? Well, I don't have an integer exponent that I can write 2 to the power of to get 9. I do know that 2 to the third makes 8, and 2 to the fourth makes 16, okay? And I know 9 is sandwiched in there somewhere, so 2 to the something power to give me 9 has to fall between 3 and 4. And if I want to plug this in on a calculator, I do log of the 9 argument divided by the log of the base of 2. Make sure you close those parentheses. If you don't, you'll get an error. You get 3.170, which is between 3 and 4. Next one, again, this is saying 3 to what exponent makes 36? Well, I can't write an integer exponent for 3 to some of that power. Ugh. Can't write 3 to some integer exponent power to give me 36. But I know that 3 to the third is 27, and 3 to the fourth is 81. I know that. So now 3 to what power gives me 36? Well, that integer is somewhere between, well, that value rather, is somewhere between 3 and 4. If I do log 36 divided by log 3, calculator gives me 3.262. Okay. Next one, all right, so again, 4 to what exponent gives me 21? Well, 4 squared is 16. 4 cubed is 64. So something between 2 and 3, which are these exponents, is going to give me this one. So log 21 divided by log 4. I get 2.196. Okay, I think you get the gist here. I'm running low on time, so I want to make this connection here. Just know that these are the same thing, and that we call this the change of base. Okay, there you go.